everyone. So I'll be discussing the third part of sixth experiment. So here we'll be doing the reconstruction of the ADC's analog input signal through DAC. So as you can see the interfacing diagram, whatever the input we are giving, the same output we are getting through the pin PA4. So we'll be using the input pin PA1 as our ADC IN1 input pin, and CPU will process that ADC data and give a digital data to the DAC, which converts the digital data to analog, and we'll get a similar output as our input. So you can see here that here the settling time is 3 microseconds. So for 3 microseconds time we have a sampling time of 112 cycles. So the only change here is that in the rank the cycle will be not chosen as 3 but it will be chosen as 112 cycles. So the configurations are same. So let's get started. So I have opened the STM32F407VG. So I'll be clicking on access to board selector. After doing so, we'll again type the name of the board, STM32F407VG disk 1. Oops. Yeah. So we'll double click on the board. Then we'll click yes for all default mode peripherals. Let it load. First step is that we have to clear out all the pinouts. Yes. After clearing all the pinouts, we have to go to system core. RCC as usual. We have to set high speed clock as crystal ceramic resonator, and in our SYS we have to set debug as serial wire. Next up we have to go to analog, then we have to go to ADC1. We have to check IN1 so that our PA1 is our ADC input. After doing so, we have to move on with DAC and check out1 configuration. As you can see, our PA1 is our input which has been set automatically, and our PA4 is our DAC output. So after that we are just going to change our parameter settings of rank to 112 cycles, and then we are going to set our clock configuration. Choose your clock configuration as HSI and set the AB2 peripheral clock as 60 MHz. I'll do that. After doing so, you can see that my AB2 peripheral clock is 60 MHz. Now we can move back to our parameter settings. In that you can see that it is PLK 2 divided by 2 because our clock prescaler will convert our 60 MHz clock signal to 30 MHz clock signal. All the settings are as normal. Only the change is in the sampling time because our T setting time is 3 microseconds. Our DAC setting should be software trigger, and wave generation mode should be disabled. Assuring all these configurations are done properly, we can move on to our next step of generating the code. When we click on open project, it will open our project. Make sure your DAC configurations and your ADC configurations are as given in your manual, and your sampling time is 112 cycles. Set the target setting as shown in the 6A experiment, and then go to application/user/code, then go to main C, and then write in your code which is given in your manual, assuring that all the handle type defs are there, and please write the code which is given in the manual correctly. Then click on build and check for the errors. Then plug in your board into the system and click on load to upload the code onto the board. Since we are generating a waveform, we'll be using a waveform generator. So the W1 here is your waveform generator, which we'll be connecting to your PA1. And since your output is coming from the DAC of PA4, we'll be connecting our scope channel 1 positive to our PA4, that is our orange wire to PA4, and then we'll be grounding both the wires, ensuring that grounding is done properly to avoid the damaging of the device. Open up your waveform software from the system, click on WaveGen. So after clicking on WaveGen, you can see that these configuration will show up. On the channel 1, you have to click type as sine. Frequency should be 1 kHz. Since in your tabular column you are starting from 1 kHz, you have to set it as 1 kHz. Your amplitude is 2 Vp, V peak to peak, so your amplitude will be 2 volts. Offset is given as 1, so 1 volts. Symmetry should be 50%, phase should be 0. After doing this, move on to your scope of your channel 1. The configuration will be as shown. In your scope, uncheck the channel 2 and check the channel 1 and keep the settings as shown here. Keep the offset as 1 volts, keep the range as 5 millivolts per division and position as 0 seconds and 1 milliseconds per division. You can change these settings as per your requirements and as per your visibility. So after doing this, we'll move on to the main experiment. Moving on to the main experiment, in your scope, go to view, click on measure. After clicking on measure, click on add measurement, channel 1 horizontal, and click on frequency, which is here. So after clicking on frequency, you have to click add. This is your second column of your table. Here you'll be measuring the input and output frequency and noting it down. You'll be also noting the shape of the output waveform through DAC, and please note down the shape and write the observation of the given output through DAC.